All right, hi Year 12s, this is Mr. Lim here again, and this is another special request for question 26 of the 2019 exam. Okay, so let's have a look at it. It says, dilute hydrochloric acid is added to 3 labeled test tubes, one with copper metal, one with copper oxide, and one with copper carbonate. Okay, so hydrochloric acid added to these 3 things. Now, it's important to note that these are all in excess, which means that if there is a reaction, you're still going to have some stuff at the end of it. So that's something important to recognize. All right, so let's have a think about what will actually happen. I'm not going to answer the questions yet. Let's just think about what will actually happen. So the copper metal, the copper metal with the hydrochloric acid. Will this react? Okay, so remember, the acid reaction with metals is a redox reaction, not an acid-base reaction. So if you might remember an acid-base reaction, you just remember that acid plus metals make salt plus hydrogen gas. However, it's actually a redox reaction where you have to consider whether the acid is strong enough to oxidize the metal. Now, if you look at the HCl, that's the H plus goes to H2 reaction, which is at 0 volts. Okay, it's the one they compared everything else to. And then the copper is actually above it. Okay, so the copper 2 plus goes to copper, and you got some electrons over here and some electrons over here. So you recognize that this second reaction actually goes backwards. Okay, so it's going to be copper goes to copper 2 plus 2E minus. Okay, and so the idea is that if the metal is above the acid reaction, because it's got a value of positive 0.34 in the opposite direction, okay, then it's not actually going to react. So this excess copper metal does not react with the dilute hydrochloric acid. So this one technically is no visible reaction, okay, because the copper, like silver and gold, the acid is not a sufficiently strong oxidizing agent to react with the metallic copper, silver, or gold. All right, so the first one, no visible reaction. Okay, the second one, the copper oxide. Okay, this is an acid-base reaction, right? The copper oxide goes plus HCl, will react, and it turns into copper chloride, copper 2 chloride, and H2O. You just got to balance that out. That's that reaction there that will occur. All right, and then the copper carbonate with the acid, again, is an acid reaction. H2O plus CO2 plus CuCl2, and again, you got to balance that out, and everything's balanced. Okay, so those are the reactions. Let's go have a look at the questions now. Describe the contents of the first and second test tubes once any reactions are complete. Okay, so the first one, there is no visible reaction. So what are you going to see at the end of this thing? Okay, you're going to see the copper metal still there, so it's the salmon pink solid in a clear colorless solution. And if I had more space, I'd write that out. All right, so that's what you'll see. Considering no reaction will occur, that's what you started with, that's what you're going to end with. Okay, what are you going to see in the second reaction? Now remember, it is asking only for what occurs at the end of the reaction. Doesn't actually ask for what's at the beginning, and so I know. So the examiner's report said that there's lots of kids who actually wrote the reactants and the products as observations, and you didn't really need to. You only needed to write the products as the observations. So what's going to occur? You're going to have copper chloride and water. So you're going to have a blue solution. That's why I'm using the blue pen. Blue solution. And remember, because it's in excess, you're going to have the copper oxide there. And if my memory serves me, copper oxide is black in color and black solid. So you've really got to remember that this is in excess. So there's still going to be the copper oxide still there, and it's a blue solution and a black solid, and there's no gases formed. All right, that's that one there. Let's have a look at the next one. Write the balanced equation with appropriate state symbols for reaction that takes place between copper 2 oxide and hydrochloric acid. Okay, so the copper 2 oxide and the hydrochloric acid, you've got to be thinking that what will occur. So we already wrote what will occur. It's going to be this reaction over here. However, I know it doesn't say to write an ionic equation, but you should always write an ionic equation. All right, because that's just generally what they want and what they expect. So let's write out the ionic equation for that. The copper oxide, remember, it's because it's a solid, we keep it together, plus the hydrochloric acid. Now, for hydrochloric acid, I know that the chloride ion stays in aqueous form, so I'm not even going to add it. It goes to, copper 2 plus ions plus water. Okay, and then I'm liquid. Then I'm going to balance that out, and that's all you need to balance it out. All right. So I know that sometimes we harp on about it'll say write an ionic equation, and then you write an ionic equation, but generally they're expecting ionic equations all the time. So if you can write an ionic equation, just write it anyway. Okay, because it's not incorrect if it's an ionic equation. So just do it. So if the labels of test tubes 2 and 3 become smudged, describe all observations that could be used to distinguish between these two test tubes once any reactions are complete. All right. So once they are complete, what could you use to distinguish between them? All right. So you can be talking about, well, there's the presence of bubbles in the second one, in test tube, in test tube 3. Okay. You could be using the fact that there's the excess solid, right, is different colors. So the excess solid, the copper oxide is black, and the copper carbonate, I believe, is green. You could also really test the pH if you really felt like it. The pH will be lower in, oh wait, never mind, no you can't. All right, because acidic metal oxides are acidic, and so therefore you're going to end up with, metal oxides are basic, and, well actually, I guess you could use the pH, but it's not going to be in the scope of this course to discuss that. But really those would be the two things, where you're going to see bubbles of the CO2, and you're going to be able to see the excess solid as the different colors. All right, those would be the two main ones. And so that is how you answer question 26 from the 2019 exam. That's it. Adios.